You now know the core of Python. In this episode, we go one level deeper. Generators, decorators, and the standard library tools that make Python code faster, cleaner, and more professional. These are the concepts you will see constantly in machine learning codebases. A regular function computes all its values and returns them at once. A generator produces one value at a time using the yield keyword. When Python hits yield, it pauses the function and sends the value to the caller. The function resumes from exactly that point the next time a value is requested. Calling next on a generator fetches the next value. This is memory efficient because the generator never holds all values in memory at the same time. You can loop through a generator with a standard for loop. Python automatically calls next on each pass until the generator is exhausted. Generators are the right tool when working with large datasets that would be too big to fit entirely in memory. Machine learning frameworks like PyTorch use generators internally in their data loaders for exactly this reason. A decorator is a function that wraps another function to add behavior before or after it runs, without touching the original code. Here, shout is a decorator. It defines an inner function called wrapper that prints a separator, calls the original function, and prints another separator. We then reassign greet to the wrapped version. Calling greet now runs the wrapper, which includes the original logic plus the added behavior. Python provides the @ symbol as clean shorthand for applying a decorator. Placing its shout directly above the function definition is exactly equivalent to writing greet equals shout of greet after the function. The result is identical. The @ symbol syntax is what you will see in real code bases. You will encounter this constantly in frameworks like Flask for routing and PyTorch for custom layers. The collections module is part of Python's standard library and contains several highly useful data structures. Counter automatically counts how many times each item appears in a sequence. Here, we count word frequencies in a list. The result is a counter object that behaves like a dictionary with counts as values. The most common method returns the top items sorted by frequency. This is used heavily in natural language processing for word frequency analysis. A default dict automatically creates a default value when you access a key that does not exist yet. With a regular dictionary, accessing a missing key raises a key error. With default dict, you pass in a type like list or int, and Python creates a default value of that type automatically. Here, the first time we access the key Alice, Python creates an empty list for it. We then append scores directly without checking whether the key exists first. The itertools module provides tools for efficient looping. Chain joins multiple sequences into one continuous stream without creating a new list in memory. Here, we loop through list A and list B as if they were one. Combinations generates every possible grouping of a given size from a sequence. Here, we get every pair from 3 items. Itertools functions return generators, so they are memory efficient and fast even with large data. The functools module provides tools for working with functions. Partial lets you create a new function by pre-filling some arguments of an existing one. Here, we create square and cube from the power function by fixing the exponent. Square always uses exponent 2. Cube always uses exponent 3. Reduce applies a function cumulatively to a sequence, combining items one by one. Here, we use reduce with a lambda to sum all numbers in a list, starting with 1 plus 2, then 3 plus 3, then 6 plus 4, giving 10. That brings us to the end of our Python training. You have covered everything from the fundamentals all the way through to the advanced tools that professionals use every day. Generators for memory-efficient data streams, decorators for wrapping functions cleanly, and the standard library modules that power real production code. You now have a solid, complete foundation in Python. Put it into practice, build things, and keep writing code every day. That is how it truly becomes yours.